Okay, so our first unit is on thermochemical changes. Same stuff as always, by the way. I'll always make sure I give you all of the notes. Just write down the stuff we talk about. So the first thing I might point out is what is, you guys don't have this slide, probably. And what does thermochemical mean to you guys? What does thermal mean? Heat. Yeah, heat. I mentioned the two words earlier. I'm sure they're in our notes at some point, endo and exothermic. Basically, this unit is going to focus on how, in order for a chemical reaction to occur, there has to be a transfer of energy. Energy is kind of a key concept in science in general. But in terms of this unit here, pretty much all chemical reactions, no, not pretty much, all chemical reactions either require heat, which makes them endothermic, or will give off heat, which means they're exothermic. How much heat they give or take, differs from chemical reaction. I talked about dynamite earlier. There's one where basically a small little stick of dynamite causes massive destruction. And I mean, as scientists develop newer technology, now you start looking into things like C4. Same thing, small little packages of stuff, and it can. So those are violently exothermic. Endothermic would be something like, anybody ever crack open one of those packs? It's supposed to be like a cold pack to put on your knee or something if you sprain your knee. So basically, we're talking about the study of heat and how it applies to chemistry. So our first topic is really, really basic. First day topic. I need you guys to be aware of probably the two most common initial sources of energy, and that's photosynthesis is the first place to start. Okay, 12s you guys did bio already, right? 11s you guys haven't though. Are you guys aware of photosynthesis? You guys heard this word before? Okay. Photosynthesis basically in a nutshell is how the plant system gets energy from the sun, uses chlorophyll in chloroplasts, and basically creates a sugar. Okay. I don't know that we as society would be able to live and function if it wasn't for the way this works. Because most of our dietary needs are really based off of us eating stuff that comes from the sun. And when you even look back at it indirectly, this morning I had cereal. Well, where did cereal come from? Well, I mean, it was made from some grains. Grains are plants, and plants grow because of the sun. Right? Similar concept, though, with the milk I poured in my cereal. How did the milk get formed? Well, it came from a cow. How did the cow live? Well, the cow ate some grains, and the grains came from plants, which came from the sun. Does that make sense? So photosynthesis is pretty much like a fundamental process behind where a lot of our energy as humans comes from. So if you don't know the equation, here is the chemical equation. Take carbon dioxide and water. By the way, water needs to be a liquid for this to happen. I should point out that one. It's actually a very, very small distinction, but it actually comes up on diploma questions a lot, where they ask you about the equation. And, I mean, think about a plant. What sort of state of matter does a plant need water to be? When I go water a plant, I use liquid water to water a plant. Yeah, exactly. You put steam on a plant. So, do you guys know this molecule? Glucose, sugar, basically. Yeah, this is glucose. Glucose is this guy right here. And oxygen. Okay. In case you need to balance it, this is the easiest thing in the world to balance. All of these need a 6. Yeah, it kind of is, isn't it? Yeah, they're all 6s except for the glucose itself. So, does that work so far? Okay. Maybe you've heard of this other formula. It's basically the opposite of photosynthesis. It's called cellular respiration. And this is where basically a plant will use that energy up and breathe it back out and use the energy. It's just the complete reverse reaction. So it takes the sugar and oxygen and it produces carbon dioxide and water. Okay. Same thing. Water, I always need to look this one up just to double check. But for right now, let's put this one as a liquid. Okay, but I need to double check that one. I always should add a slide, and I always forget to. There's one more type of reaction that you should know about before we do anything else that involves energy, and it's called a combustion reaction. Maybe just like throw an extra slide on here. You're also expected to know about combustion. How does combustion work? Okay, well, you're going to start with something hydrocarbon. So sometimes we just write it like this, CXHY. I don't know what combination it is, but you need something with carbons and hydrogens. Add it to oxygen, and it then blows up. And it makes carbon dioxide and water. But here's the distinction I want to make. Unlike the previous two examples where water is a liquid, when you blow something up, water's probably a gas at this point now. So those are basically the three main reactions that we kind of want to start with in terms of energy producing reactions. Now I want to go back real quick and talk about the endo versus exothermic part of them. Photosynthesis, endo or exothermic? Good, it's endothermic. Why? It needs sunlight, yeah, it needs energy from the sun. Right. So it's almost like you could say plus sunlight. Makes sense? For the cellular respiration one, when you eat your cereal, it gives you energy. So this one is exothermic because it's going to release the energy back to you. I eat cereal, therefore I can go play for the Swedish hockey team. No idea why I picked that. These are old notes by now. And for the one I just made somewhere else there, where did I leave it even? There you go. Combustion. Combustion, endo or exo? Exothermic, yeah. I mean, think dynamite. When something blows up, it's going to release energy in the form of probably heat, maybe light. Kinetic energy, I guess, would be a good example. So far, so good? Okay. Another thing we should talk about just briefly is the concept of fossil fuels. Most of the energy that we have, we can probably attribute back to the sun in some sort of capacity. Even oils out of the ground.
Please excuse the interruption. Can the following students please come to the office? Curtis Bedreeston, Shelby Light, Lisa May, Jessica Monta, and Rylan Clark. Please come to the office. Dawson Van Herk and Sophie Florida. Please come to the office as well.
Okay. Fossil fuels. Alberta's a good example. I mean, we have so many different oils and tar sands and all that sort of stuff that we're trying to dig up to make money off of, right? Do you guys know where we believe that comes from? Yeah, but where do the fossil fuels come from? Not necessarily even just dinosaurs, but old organic matter. So yes, dinosaurs, old plants, old trees, whatever it happens to be, they were buried, highly pressurized under the earth, and basically it caused it to form oils, crude oils of some type. Does that make sense? Yep. And so indirectly, we can trace even back our oils to the sun, because the sun caused plants to grow and dinosaurs to live, and they then died and were buried and were crushed, and that high pressure causes them to turn into oils, and then we burn that oils in our cars. So, I mean, even our fossil fuels really indirectly do come from the sun. So I have some notes in there about that you can read. Just have a basic slide here just talking about ways that we can address energy issues that you guys can read, so I'll pause on that. We've now covered two outcomes, believe it or not. Yeah, there's two main outcomes, and they actually test these very regularly. The first one is, do you know photosynthesis, cellular respiration, and hydrocarbon combustion? Hopefully you do. Basically, you know how they work. The second one, and I kid you not, they will sometimes put this question on the test. And if you get it wrong, I yell at kids because you should never get this wrong. The question will often be, what is the original source of energy for our stuff? And the answer is the sun. Okay, they don't phrase it like that, but like they often put this question on the test. It's usually the first question. It is the sun. And I kid you not, when I look at stats across the province, like usually about 80% of the province gets it right, which is a good number. But like in my mind, I'm bewildered going, who gets that one wrong? Like what teacher does not on day one teach kids everything came from the sun? So there you go. I've taught you your first lesson. Fair enough? All right, we'll see you guys tomorrow. You guys can take off.